So today we're looking at section 6.4, which is titled nth roots. I know it's kind of a strange name. The n there is just a variable, which represents any kind of root. So we just in the last section talked about square roots. Another name for a square root is a second root. There are third roots and then fourth roots, fifth roots, sixth roots, seventh roots, etc. So any kind of root. So that's what the n represents, any kind of root. Learning targets, 2 of them. I can simplify radicals, and then secondly, we'll use a calculator to approximate radicals as well. We'll spend more time on the simplifying than we will on the calculator. So first of all, I want to define something for you. If we consider the number 25, what number or numbers can be squared to give you 25? 5 squared gives you 25. Is there anything else? Is there any other number you can square besides 5 that gives you 25? Any other number besides a positive 5 that can be squared? Negative 5 can, right? So when we talk about the square root of 25, we get 5, and that positive 5 is what's called the principal square root. So if we want the other one, and sometimes we want both, and we've dealt with that, but if we want one of them, the principal one, we would not put the negative in front. We would just say square root of 25, and we interpret that as a positive 5. If I wanted the one that's not the principal square root, I would put a negative in front of the square root. So if we see this, they're talking about the one that's not positive. So what would you say for the negative square root of 25? A negative 5. What if we wanted both of them? That's when we would say plus or minus, and that would mean that we have positive and negative 5. To be clear, when we are solving quadratic equations like we've done before, when you introduce the square root, you're trying to find x, you're trying to find all of the answers, and so we use the positive negatives because we want them both. Today's section, we're just simplifying. We're not trying to solve anything. So you need to use or give the root that's consistent with what they asked for. So let's jump in and try to make some sense of that. Okay, so first, let's give plus or minus square root of 36x to the 10th. Now, square root of 36, we've of course dealt with that, but we haven't really been putting variables in there. We know that a square root is the inverse of squaring. So then I would ask the question, hey, and I'm not going to do this every time because I don't think you need to do it every time. But if the square root is the inverse of squaring, what was it that was squared that gave you 36x to the 10th? That's 6, but what about our x? X to the what power? X to the 5th. Because if I work backwards, I'd have to distribute that square, and it would get multiplied to an exponent that's already there. And so now at this point, the square root and the square cancel each other out. So I'm left with plus or minus 6x to the 5th. Since the problem started with plus or minus, I have to include that. Yes, question. Yeah, I'm not, like I said, I'm not going to write it as a perfect square like I did that time, probably ever again. That was more just to explain. So let's kind of maybe try to shortcut the process. Let's go with Oh, let's try the fourth root of 16 t to the 16th. Notice the little 4 that's written in front of the square root. I want to be very clear. There is a difference between these two things. What does this first one mean? 4 times the square root. All right, that's what we've dealt with before. What does this mean right here? It would be called, we actually call it the fourth root. Now, notice the difference about the 4 in the two problems. When we're talking about a root, it's smaller font size. It's kind of a superscript. It's up above, but it's really kind of fit right there in that spot on the radical or the square root sign is where we would put that number if it's a different kind of root. So that's what I intended here on number 2. This is not supposed to say 4 times the square root. This is actually the fourth root of 16 t to the 16th. Notice the sign in front of the root. It's positive. That means I'm looking for the principal root. So our answer is going to be positive. What is the fourth root of 16? Now that's the inverse of saying, you know, we have a number to the fourth power. That gives us 16. We're trying to work backwards. We're trying to figure out what number do you take to the fourth power to give you 16? And it would be 2. 2 times 2 times 2 times 2. That's what the fourth power means, is 16. So the fourth root of 16 becomes 2. What do you suppose happens with the t? It will be not t to the second, t to the fourth. So we know off to the side, just a little note in case I confused you on where 2 came from. We know that 2 to the fourth power is equal to 16. So then if I work backwards, the fourth root of 16 equals 2. Those are, you know, inverses. That's how I knew it was 2. I could have written the whole thing as a big power of 4. I told you I won't really plan on doing that, but here I am doing it on this problem. But I could have written it as 2, and then that would have to be t to the fourth because we would multiply the 4 and 4 to get the 16. So really I'm using division when there was an exponent involved. Let's try some more. Let's do negative. We'll go back to a square root. Square root of 49 u to the 8th v to the 12th. What sign shall I put on my answer? The negative, right? This is not talking about the principal root, not the positive one, it's the negative one. Square root of, let's start with the 49, because it is a square root this time. U to the 4th, v to the 6th. You may not realize this because we've never done it before. When it's a square root, there's actually a 2 right here. A square root means a second root. We don't bother writing the 2 because we just understand, it's kind of an understood thing that there's a 2 there. But when we're dividing by a 2 because a square root has a 2 there. It's a second root. Let's think about this problem. Go back to a square root again. We'll look at some other kind of roots shortly. The square root of, this is an expression to the 8th power. What shall we put for our answer? It'll still be a y minus 6. But now what is its exponent? 4. So I had to divide it by 2. And it was positive. Let's look at another root again. Let's look at a 4th root. Again. The 4th root of 81, g to the 16th, z to the 24th. Well, let's start with the 81. What is the 4th root of 81? 3, because 3 times 3 times 3 times 3 is 81. So that does become 3. What about the g? G to the 4th. If it's a 4th root, I'm dividing the exponents by 4. Then so z would be z to the 6th. How about the 3rd root of negative 125x to the 6th? Is there anything illegal, so to say, in this root? We've never been allowed to have a negative inside the square root, right? Except we did if we gave an imaginary root. But this isn't a square root, it's got a different set of rules. Is there a number that you can cube that would give you negative 125? Negative 5 does. Think about a number to an odd exponent. We were dealing with squares before, but if we have something to the 3rd power, that means I'm taking negative 5 times negative 5 times negative 5. What's that ultimate sign going to be? It's going to be a negative 125. So as long as your root is odd, like it is in number 6, it's okay to have a negative inside. It means my answer is going to be negative. So I get negative 5x to the 2nd, x squared. Odd roots can have negative numbers inside. That is not a problem. We're going to take a look now at the 2nd learning target. The 1st learning target was being able to simplify radicals. Our 2nd learning target is to be able to use a calculator to approximate radicals. If you want to grab a graphing calculator, if you don't have one, that's not a bad idea. Other calculators, scientific calculators, can do this. If you're relying on your phone calculator, it may be able to. I'm not sure. I don't know how reliable that is. So we use a calculator. So use a calculator to approximate the following. We're going to round to 3 decimal places. Before we do this, we got to make sure we know how to do that on a calculator. So we're gonna in a moment try to figure out what the 5th root of negative 43 is. So the way that you're going to do this, if you're using a graphing calculator, if you click on the math button, and it's a button on the left side, it's right below your second and then alpha buttons. If you click on that math button, there's a lot of options there, but 2 of the options can be helpful, one in particular. Now, if you look at the math button, at least on the school graphing calculators, your 4th option, then your calculator might be a different number. But I see this as number 4. What kind of root do you suppose that is? A cube root or a 3rd root? Is that what I want for number 7? No, but sometimes I can use that. Right below that, the 5th option is an x root, which means we can do any kind of root that we want. I will tell you that if you have your own graphing calculator, and if it's not a terribly new operating system, you might have to, before you select that button, hit like 5. If it's a 5th root, you might have to hit 5 and then go push that button. But if you're using one of the school graphing calculators, you shouldn't need to do that. You should be able to, on number 7, go ahead and select that button. And then there's a spot for you to type in the 5 in that position. If you click the button and it doesn't like bring you to a flashing spot like that, then that means you probably had to hit the 5 first. But if you have a graphing calculator, just put a 5 in that spot, then you can arrow to the right, type in negative 43, and then it will do the work for you. It says to round it to 3 decimal places. Negative 2.1217. Those are the first 4 decimal places. So hopefully you're good at rounding. Look at the 3rd decimal, it's a 1. Then decide, do I have to round it up or not? So you look to the number to the right to see if it's 5 or bigger. In this case, it is. So we have to round the 1 up to a 2. So number 8, don't need to spend a lot of time on this because once you know how to plug into the calculator, you're good, because we're letting the calculator do all the work. But go ahead and try it out yourself. See if you can find the 4th root of 71. You should get an answer of 2.903. It was 9027, but I have to round it up. All right, and that is actually the end of the notes for today's section.